Ready? All right, so we're recording. So happy March 8th. It is International Women's Day. So yeah, let's give it up for all the women. Everybody. Yeah. Yeah. What does that mean? Oh, W. Yeah. I can't do that. You do that without, can you, do you have to use your other hand across them, or can you do it with, oh, wow. Wow. That's good. That's good. Yeah. Happy Women's Day. Okay. Now listen carefully about the test. It was a nice test. It was substantial, and the grades were probably lower than what y'all are used to. But that's okay, because here's what I'm going to do. It's an AP class. It's a level 4 class. If I allowed you to retest, I would go to prison. It's not allowed. Okay. Yeah. So I'm not going to do. Yeah. We can't retest in a level 4 class.
Not even like a finished prison, but like
not even at like a detention center. We're talking like the big house, you know.
Like, because finished prisons are nice. Have you seen a finished prison
in Finland?
In Finland,
no,
yeah.
But someday I hope to be there.
Yes.
Yeah.
If you want to get arrested in Finland.
I'll go back to my Mutterstadt and do a crime.
Yes.
Yeah. All right. Here's what I'm gonna do. I'm gonna allow y'all to do corrections to earn up to half of your points back. So if you want to see what that grade, y'all are math people, stick a 1 in front of your grade and divide by 2, right? So if you made a 70 the first go around, you can get back to an 85. All right. Now here's how you do your corrections. We're not going to do them in class. On a separate piece of sheet, you're going to, if it's a multiple choice question, you're going to write it down. It could be a little piece of sheet, right?
No,
or if you're like Jackson, it could be a big piece of sheet.
My sheets are always big.
Yeah, yeah. If it's a multiple choice question, you're going to write down the question and you're going to treat it like a free response, like a short answer. You're going to show the work for it exclusively, and then I want you to write a little sentence, like short sentence, not like little where I can't read it, like it's too small, but a short sentence just communicating to me and yourself why you missed it, right? Like, oh, I took the derivative instead of integrated, right? Yeah. Don't say something like I didn't know the answer. I didn't know the answer, or like I didn't study. That's too vague. I want it to be something very specific. I forgot parentheses and I didn't distribute my negative, something like that. Okay. And then on the free response, I realized that for part A, there was not enough room really to fit those in there. I did on the key, some of y'all did, but if that's ever the case, including on the AP exam, don't let space, the economy of space, limit you from, earning points and spreading out. So you can always ask for an extra sheet of paper, and here, of course, you can always do it and put C attached. So if you missed any piece of the free response, any piece at all, in other words, if you didn't get 9 out of 9, I want you to rework the entire thing over again. Okay, on a separate sheet of paper. Okay, on a separate sheet of paper. And what I'll do is I'll go back through and I'll actually grade your corrections, right? And when your corrections are correct, I'll give you half the points back for that problem. Okay, so the purpose is for you to, of course, revisit your mistakes. It's like an open note test now. You can communicate with others, right? If you need to speak with someone else to glean the knowledge or the information, just make sure that you have it and you own it when y'all walk away from that session. You can look at, I can even help you with it, right? I hope. And if I can't, well, anyway. But here's the deal. Once everybody turns in their corrections, then if there's still a problem that's kind of sticky, then we'll go over it as a group, okay? Now, I will mention one sticky one that a lot of people kind of fell short on, and it was on the back, number 7. Number 7, a lot of people correctly identified U substitution because your inside function was linear and you were off by a variable. And when you completed your U substitution, and plugged it back in, the answer wasn't there. So on that one, you have to factor out least powers to match it up to the answer choice, which was D. But also remember that if you have an answer and it's not there, because your answer choices were antiderivatives, if you had the time, you could go through and take the derivative of the answer choices and match them up to what you have, right? It's back solving. And so you don't have to do it for all 5 choices, but maybe you think it's one or the other and you do that. So it's a little bit easier going forward than it is going backwards. So that might be one that even in the end, I'll end up going over with y'all. But let's let these corrections be due. Would be 20 minutes be enough? No, let's make them do, let's see, Tuesday, Wednesday. The end of the 9 weeks is this Friday. And I know y'all are fully aware that this is the last 9 weeks where grades affect class rank. After this 9 weeks, your rank, not your GPA, but your rank is locked. Okay. So that means the last 9 weeks, you can just shut it down, right?
Don't fail.
No, I was being facetious, right? So anyway, let's make these do. I want you to take your time doing this, and I know you got a lot on your plate. So let's just make them do Friday. If you get them done before Friday, you can turn them into me. Okay. Friday at the start of class, everyone should have their corrections. Now, if you didn't miss anything, then you can write me a limerick instead and turn that in as your correction, and I'll give you half your points back.
Jackson gets the points from that.
Jackson will get the points. Yeah. You write me a limerick and I'll give you bonus points, because everybody deserves to get something back, right? In the corrections, the rich don't get richer, right? The rich just get more time because they don't have to do any corrections. Here's the other thing that I think is kind of important. The math club is tomorrow. I was out last time tutoring. Who's doing the presentation?
The one that hasn't been here.
Jensen? Oh, okay. But remember, during advisory on non-math club days, there is tutoring down in the commons area. And I know that Landon and Devin kind of are down there every time. And there's a steady stream of underclassmen that ask for help with other things. But two things, you're always welcome to go down there as well to either A, help assist tutoring the struggling students, or B, if you are the struggling student, you can take advantage of Landon and Devin's expertise and kindness. Okay.
I got a 73 on my math test. I needed to get some test corrections done, but I didn't know how.
Yes, case in point. Yes. Okay. Yes. So if you want to go down there and volunteer to tutor, that's fine. But you could take advantage. They were in here this morning and they did slope fields again. Are you going to do it in seventh? They're going to do it again in seventh period. There were 2 people here. And I know what those 2 guys are like. If there was only one person here, they would still do it as if the room was packed, right? In fact, I imagine if there were like no one that showed up, like I do on a Saturday morning, they would still teach to an empty classroom, because dang it, the rats have to learn too, don't they?
Do you teach to an empty classroom sometimes?
I do. And by third period, after marking everybody absent, I like, dang, it must be Saturday. And then I realize it, and then I go home. Yeah. Just creature of habit. So do it on a separate sheet of paper. And then when you're done, we will staple your corrections to the back, so that when you turn in your packet, you're still seeing the front of your test and your original grade. Okay. And I'll find them. If you start by saying test corrections at the top, I'll find them. Remember that we also always staple in the top left corner by our name. I know a stapler can actually work anywhere on the paper, but that's where I prefer you to staple it. Uniformity. It's just easier for me when I flip through and I'm grading them for them all to be stapled in the same place. Right, Hank? No, not on the bottom. Yeah. And different. I'm not real picky about it, but it's just kind of nice when we grade it that way. All right. Okay. Any other comments or questions about the test? On Friday, we'll go over any questions that still linger. All right. We're not going over it right now. Okay. I'm going to give you a chance to revisit your mistakes, use the resources out there to help you get through it. Okay. So what are we going to do right now? Well, we're going to go to town. Boy, howdy, we're going to town. There's a song by Robert Earl Keen that you just reminded me of, and it's called Guess What? I'm going to town. I'm going to town. It's a Saturday night, but it's really just what? It's a Tuesday afternoon. All right, so I didn't put it in Canvas yet. The AP classroom for tonight, everything that we do from this point on, except the corrections, is going to go on the next 9 weeks. Okay. So your grades are pretty much locked, other than these corrections, which can do a really big part in boosting. And the reason is because there's so many people out, I'm not going to have so many incompletes. Okay. So, yeah.
About the extra worksheets, are those going to be bonus?
Yes. If you have till Friday to get your worksheets in, remember starting at 3.8, those are all optional. So their folders are open. They should be 3.8, 4.1, 4.2, 4.3, 4.4, and we'll do 5.1 as well. So those are 5 worksheets. No late fee on those. If you get those turned in by Friday at 4:20, we'll do Friday at midnight at 11:59. Then I'll look at all of those, and I'm going to create a column in the test category that says test bonus. Okay, and then I'll just go through, and that's where I'll put those points. And so they'll get added to the aggregate sum of your tests. So it's basically, let's say I gave you +8, you could take those 8 points essentially if you want and put them on any one of the 3 tests. It'll add up to 3 test grades and then add those bonus points and divide by 3. Okay, so you have till Friday at 11:59. And also another reminder that all the AP classrooms should be wide open. So, and I haven't gone through none of those grades yet, because for me, once I go into a folder electronically, in my mind, I don't go back to it. So I'm going to wait until the deadline to get those in. Okay. So you have till Friday 11:59 to get caught up. I don't want to give you all of spring break unless I absolutely have to, because I want you to enjoy spring break, and that means putting as much calculus in it as you want, not as is required. So I want y'all to be done before then. Okay, and look, the AP Calculus exam is what, in 61 days. There's still a lot of information out there that we have to cover. Are y'all worried about me getting through it? I hope not. Let me do the worrying. I'm not worried, I'm just concerned, but we'll get it done. All right, a little bit different mindset. So what's that? Yeah, don't turn around. Look up here. Look at it. All right. All right. So here's last year's group on the morning of. So after this year, that'll be y'all. Right. That'll be y'all. And look at, they're all wearing masks. What an iconic photo. And look at Terrence. Terrence is just like, what? Right.
He's doing the same thing right now.
Yeah. Terrence is not, he doesn't participate much. All right. So we're on 5.2. So maybe I can get through this today. Landon's already gone over this in one session, right? But nobody was there though. There's one today during 7th period. Yeah, and it's going to be over slope fields. So you can decide whether or not it's worth you coming. There was some AB students there this morning, 2 of them, and they haven't even done anti-differentiation yet. But
Wait, have they actually not?
oh, have they? They've done 4.1? They are? Oh, okay. Okay. My bad then. My bad. So they did understand the integration. I didn't know if they did or not. Okay. Well, good. So here we are at slope fields. Slope fields, slope fields, slope fields, slope fields, slope fields, slope fields. It kind of sounds fun, right? Like maybe a place you want to hang out over spring break, right? Yeah. So in this case, a slope field is nothing more. And when we say field, we're talking about like a 2-dimensional vicinity with a X and Y axis superimposed over it. Okay, that's our 30-minute warning, right? Okay, and of course it has slopes in it. So at its most basic definition, here's what a slope field is, right? A slope field is nothing more than a graphical general solution to a differential equation. That's what it is. So in 5.1, we found general solutions and particular solutions to differential equations analytically, right? Analytically, we were able to separate the variables, integrate both sides, and solve. But for a lot of times, for a lot of equations, differential equations, you can't solve them, or at least you can't solve them by separating the variables. I had that conversation with you at the beginning, right? Sometimes the capstone course of calculus is called DiffEQ, where you learn a bunch of advanced techniques for solving them. So one of the techniques, if you can't separate the variables, is to create a slope field. And what it does is it doesn't give you the equation, but it gives you a visualization of what the solutions look like, okay? Now, a particular solution to a slope field is a continuous function, that's important, that passes through an initial condition. And in this case, the word initial doesn't correspond with t = 0. It's just some point that satisfies the antiderivative, okay? So you've probably seen slope fields before when you look at like weather reports, right? Weather maps, because another name for a slope field is a vector field or a flow field. They're interchangeable. So this is a vector field simply because these little line segments have arrows on them. So it's directional. So you can imagine this is the Middle East, right? But maybe I could have found a weather report for like, Eastern Ukraine, right? But if you were to drop in like as a feather, like in that Forrest Gump opening and closing, like let's say right here, you could actually determine where you might end up if the wind currents took you, right? So that's what you could see all the different possibilities, right? If you dropped in over here at, as Wenzel says, Bahrain, right? He likes that. You could actually see where you would go. So depending on where you drop in as a floating feather, you're going to be pushed along by those currents, okay? The only difference between a vector field and a slope field is this. We don't put arrows on the end of our line segments. We just leave them as little line segments. And we can imply then that the arrows are on both ends. So we don't just go in one direction. Will they ever get back together? I doubt it. We actually go in both directions, right? 1D, yeah. Okay, so anyway, let me show you what I mean. I'm going to draw a slope field for the differential equation dy dx equals x squared. I don't need to create a slope field for this one because this one is easy to find the general solution for. In fact, before I find the general solution, graphically, let's find the general solution analytically, all right? Now, this would be one of the easier differential equations because notice it is a function of my independent variable, right? So when we did these in the beginning of the year or in the beginning of chapter 4, we just went straight to the antiderivative of dy dx is y, and the antiderivative of x cubed is 1/3 x cubed, okay, plus c. And that would be the general solution. So we didn't go into the separation of variables. And you wouldn't really have to here. If this showed up as a free response and you were supposed to show the separation of variables, it would probably more than likely, like your test did, use the separation of variables. So what would that look like? It would just look, a little bit differently. It would be this, and then you would multiply both sides by dx. Let me give myself some room here. And you get dy equals x squared dx, right? That's the separation of the variables. And then after that, you sneak in that, a lot of alliteration right here, the slender, slinky, svelte, slithering integral symbol, right? And then what would be the antiderivative of dy? There's like an implied 1 there. It would be y, and we wouldn't need the plus c because ShamWow goes to the right side. And then we get 1/3 x cubed plus c. So we get the same thing. But if it's already a differential equation that's a function of your independent variable alone, unless it says to show the separation, you can go straight to here. Otherwise, when in doubt, this always works, right? Okay, so what would the general solution be? It would be a family of cubic polynomials, right? And we know the cubic polynomial family looks kind of like this. And what would be the plus c? What would that do to each of them? Yeah, shifted how? Up or down, right? So the c didn't change locations like it did in 5.1 when we were solving for y. So this one is still going to be straight up a vertical shift. Now, I'm going to show you that we can create the graph of that family right there without ever taking the antiderivative, And to do that, we're going to create a slope field. So we're going to do it at the indicated points. College Board, if they give you one on a free response, they're going to indicate the point by putting a solid dot there. I'm just going to put a little grid and say, let's find it at all the intersections of the horizontal and vertical grids, okay? So you can almost make like a T-chart, like back in the day. You had your X value, but instead of putting a Y there, we're just going to put dy dx or x squared, right? We're going to graph the slope. Now, in this case, it's easy because I only need the X value, right? It's not a function of both X and Y. So let's just go ahead and start at the origin, right? Let's go ahead and start at x equals 0. What's the slope of the graph at 0? 0 squared is 0, okay? Now, what we do is we don't plot this as the point 0, 0. What we're going to do is we're going to plot a little bitty piece of a tangent line that has a slope of 0. Okay. What does a slope of 0 line look like? What type? Horizontal. Good. So here's what I do. At x equals 0, I'm going to graph, and I'm going to switch flavors here. You get to do it with lead on the test, right? Yummy. Lead. Okay. How big do I make that tangent line? Is that a pretty good tangent line right there at 0? Well, that's too big, right? How do I know that's too big? Because it encroaches upon the other grids, right? So the question is, how big does it need to be? Well, it needs to be large enough so that you could tell about yay big, right? It needs to be large enough so you know it's not just a single point, but not so long that it encroaches on the others. Now, 0 is one of those really, really important slopes because we can actually visually look and tell, yep, that's a slope of 0. So when you draw your horizontal slopes, make sure it's perfectly horizontal. Pretty easy with notability, right? Because we have the snap feature. But if it weren't on notability, you're going to have to draw it carefully. So when you're doing this optional worksheet, I would recommend, either doing it on paper, or if you do it on notability, don't use the snap feature because you're not going to be able to do that on the actual test. All right. Now, some of y'all are way ahead of me. Now, what about here at 0, 1? That's also at x equals 0, right? And since there's no y value in my derivative, guess what? Anytime x is 0, guess what the slope's going to be? 0. So that's going to be, in this case, up and down the vertical line. So I tell you not to use notability's features, but here I am trying to. Let me try it again. Copy. And now I can paste it, right? And then you put it right there, paste it, put it right there. And now if that works out, I could copy these as a group, paste it down here, so on and so forth. But there you go. Because there is no y in our derivative, the slope is only determined by the x value. So up and down that vertical line at x equals 0, little horizontal tangent line pieces, right? There you go. Let's go ahead and look at when x is 1. Okay, I'll just put a 1 in there. What's the slope anytime x is 1? Well, it's 1 squared, which is 1. Now, 1 is also a very important slope because what's the slope? What's the angle if the slope is 1? 45 degrees, right? So you can actually use the grid itself to help you with it, right? You go through x equals 1 and you kind of point towards, the other intersection, right? So that's your 45-degree slope. That's another very, very important one. Now, we can't physically look at that and say for sure that's a 45, but you draw it as close to a 45 as you can. All right. And now the same thing, I will paste that everywhere x is 1. Paste that everywhere where x is 1. And again, you're drawing these by hand. Each one, unfortunately, on paper is going to have to be individually drawn. There's no copying and pasting, right? But I'll take advantage of the feature here while I can. So there you go. All right. Did those encroach on the tangent pieces at 0? No. Are they encroaching on the next vertical column? No. So that's good. Could yours be a little bit longer than that? Perhaps. Could they be a little bit shorter than that? Probably not. Try not. Right. All right. Let's go ahead and do at x equals 2. What's the slope at 2? 4. Oh, now crap. How do we draw a slope of 4? Make it steeper than the 1. Now the question is how much steeper? 4 times steeper. Okay. This is where it gets into the subjectivity. It's really, really hard to distinguish between a slope of 4 and a 5 and a 6 and a 6,000 even, right? So we realize that, we being the AP calculus community. So we're not going to ask you for too many slopes that are bigger than 1. Maybe 2, right? You maybe have to save a little bit of steepness for maybe a slope of something bigger than 4. But you're not going to be asked to do a sketch of 4, then a slope of 5, then 6, then 7, then 8, because they start looking the same, right? I know that I can walk towards this door forever and ever by going half the distance, and I'll never get to the door. But physically, I just hit the door already, right? So we realize that. All right, now we can use this feature, and this is where it gets really important. If you're drawing a slope of 4, like I said, your first one is kind of subjective, but after that, you need to make darn sure the best you can that all of the other slopes of 4 in the entire slope field have the exact same steepness. So it's kind of it's not a difficult thing that we're doing, but it's a little bit tedious when you don't have notability features. Okay. All right, now let's go to -1. What's the slope at x equals -1? Also 1. Well, hey, notability allows me to just copy and paste that whole line. Oh, by the way, you're not going to be asked to put this many tangent line pieces. I've seen up to 12. That's the most I've seen. Usually it's 8 points, 8 to 12 points. Well, yeah, how many points have we already gotten? 1, 2, 3, 4, 5. We've already done 20 points, right? The most that you're going to be asked to do is probably 8 to 12. Okay. No. Just total. All right. What's the slope at -2? Also 4. Well, again, this is where it gets important. It's one thing to write slopes that are the same steepness when they're nearby, but if they occur anywhere else, they need to be the same. Okay. So the way that we grade this when we're grading your papers in the summer is we typically say, okay, let's look at the 0 slopes first. It's usually worth 2 points. Are your 0 slopes perfectly horizontal, and are they where they're supposed to be? Yes, got it. And then we look at all the other slopes and say, relative to the slope of 45, -1 is also an important one. Relative to your 45s and your 0s, and even your verticals, are all the other slopes relatively steeper or less steep? And that would be the second check. So there it is. We have just created a slope field using however many points, 25 points for the general solution. Now, if we didn't know that the equation of the general solution was a cubic polynomial, let me hide the guy over there. Could you infer that? Do you see the family of cubics appearing in here?
Yes.
Yeah. So what you need to imagine now is you're either a feather floating above land, or you have the superpower where you can not only hover, but you can visualize currents in the water, right? You could see then where the currents are taking you. Imagine that these are double-headed arrows. The current will flow both ways, okay? So this would be your general solution. Now, let's go for a particular solution. Anybody, pick just a random point that lives on
-1, 2.
-1, 2. Okay, so sometimes you might be asked to draw a particular solution once you have it. Well, this is important. The solution has to be a continuous function. So once you hit a discontinuity, you stop drawing. You don't go to the other side and keep going. All right. So Jackson picked the point -1, 2. So that's this point right here. You will be given the point. Here's the rules for drawing it. Number 1, the only point that you are specifically, explicitly required to be going through is the given point. Do I have that marked right there? Yes. And then after that, again, there's a little bit of subjectivity there. You literally go with the flow. You go with the flow. So there's not much room here on the right-hand side, but if I was looking at the current, I could see that it would launch me out at a 45. And then what would be the trend? Would it be going up like that? No, you can look at the trend. It looks to be going like this, okay? Now, you only draw it to the end of the graph, right? If you went up a little bit, 45, you only draw it to the end of the graph. You don't keep going like this, right? Just to the end of your grid. I launch out at a 45 and it looks like boom, they're decreased. I'll put an arrow there. Now we go out the other side. What's the trend on the other side? The other side looks like it's going to be like this, right? There you go. That would be the particular solution that passes through the point -1, 2. Okay. Is it continuous? Yes. Did I pass through the point -1, 2? Yes. Did I stop at the ends of the grid? Yes. There you go. That's an easy check. All right. Let's do another one. I'll pick the point this time. Let's see. Y'all pick the flavor. What goes green? Okay, good. How about the one that passes through the origin? All right. Well, what's the only point that we're going to be looking to make sure we go through? 0, 0. Okay. So I make that kind of a nice bold little dot. Now let's go up to the right first. It looks like I'm launched out of here horizontally But as soon as I get launched out, look at the general trend. It's like the arrows are pointing this way. The exit is that way. Okay. Do I have to go specifically through those points? No. Yours is going to vary a little bit, but it should be kind of concave up, increasing concave up. Yeah. And then if you go out the other side, imagine the arrows are pointing that way now. Now you're going to go out and it looks like that. Okay. Now, because Jackson's point was kind of in the corner of our slope field, we didn't really get to see the particular cubic solution. But because I chose one in the middle, and I'm glad you chose that one, by the way, you can actually see most of the characteristics of a cubic polynomial, right? So in this slope field, did we ever actually take the antiderivative of x squared? No, but can you infer then from this, especially from this particular solution in green, that it's probably going to be a cubic? Yeah. And it looks like all the others are just vertically shifts from each other. So that's the power of a slope field, right? You can visualize what the general solution and the particular solution are. And it's especially useful when A, you can't find the antiderivative. There's no known antiderivative. You're too lazy to find the antiderivative, whatever. And then B, this is nice too, because this is easy to program. You can write a program very, very easily to do this, right? Now, my programming language, I learned BASIC and I learned Fortran. So that's where I stopped. But, you know, there's people out there that could do it. In fact, here is the same slope field created in a program called Mathematica, which along with Maple are kind of the two big ones. And what it did is it created a lot more points, right? The smaller your little pieces of your tangent lines are, the more you can put on there. And remember when we talked about differentiability? If a function is differentiable at a point, what's another way to say that? Remember, we zoomed in. If it's differentiable at a point, then it is locally linear. Remember that? Like to us, the world is locally flat, but if we step back, it's curved. So if a function is locally linear, it's differentiable and vice versa. Well, if you zoom in on any function without a tangent line close enough, you'll start seeing its tangent line there. So again, as these things get smaller and smaller and you get more and more of them, you actually, it almost looks like a whole, it almost looks like they're connected. You can visualize it much, much better. Okay. All right. And that's all a slope field is. How hard is that? It's not hard at all. Okay. But we do need to get a little bit more practice. We do need a little bit more practice. Okay. So before we go to example 2, with my eyes closed, in the most basic definition, what is a slope field? A graphical general solution. Good. And it could be to a separable differential equation or not. It doesn't have to be non-separable. You can do it for anyone. Now look at this one here. Y prime equals x plus y. Is it a differential equation? Yeah, why? A derivative and an equal sign. Yeah. Okay. First of all, is this one separable? If I called this, I need to go smaller now, right? If I called this, oh, it went to favorites. That's weird. I don't even like that over there. Go away. If dy dx is equal to x plus y, do you think I'm going to be able to get my x's dx's on one side and y's and dy's on the other? I mean, we could try real quickly, right? Let's try real quickly. When in doubt, just multiply both sides by dx. Yeah. Did that do the trick? No, no. So now I can distribute the dx and I get x dx plus y dx. All right, cool. Now I need to get the y term to the other side, so I'll subtract it. Yeah, so I get negative y dx plus dy equals x dx. Did that separate the x's and y's? No, now I have a dx over here.
Why don't you subtract the negative y dx back across?
Oh, and bring it back across? Dy dx equals x dx plus y dx. That's a good idea. One step forward, one step back, right? It's like a waggle in golf. Did it hit the ball? No. But did it get us going? Yeah. Sometimes it's just a matter of overcoming the inertia when you don't know what to do. Guess what? We're not going to be able to separate these because it has to come from either multiplication or division. So Are there ways to do this later on? You learned advanced methods? Probably, right? It's a definite maybe.
Probably like 6.3.
All right. So what if we still want to visualize what the general solutions look like? Ooh, I got an idea. Let's make ourselves a slope field. Yeah. So here I took some framework off of a TI-84. And how many points do we have? 3 times 1, 2, 3, 15 points. So that's still quite a few. Notice though that your differential equation this time is a function of not just x, but x and y. So we can't just do that everywhere along the vertical line thing. So let's go ahead and just pick some random points. Let's do the origin. Okay. What do I get when I plug in a 0 for x and a 0 for y? I get 0. Yeah. So at the origin, I'm going to get a little horizontal line piece. Okay. There it is. All right. Let's just go to the right. What if I plugged in a 1, 0? And you could do scratch work here, right? If you want to do like, well, if you want to do like the point and then y prime, it might help you stay organized, right? 0, 0, we got 0. Let's go to the point 1, 0, right? What do you get when you plug in a 1 for x and a 0 for y? 1. Okay. What does the slope of 1 look like? 45. Where'd my horizontal line segment go? It was just there. All right. So 45 degrees. Make it 45. Okay. That was 1. How about the point 2, 0? 2. Okay, now I got to make it steeper than a 1. So is that steeper? Well, let's see. Is that steeper than a 1 right there? Yeah, you can tell. But you want to give yourself a little bit of room for something that might be bigger than 2. Okay. Now you can keep doing this. Let's just do it going to the left. What if I plug in a -1 and a 0 for y? -1 plus 0 is -1. Ooh, a -1. That's your 45 degree in the other direction. Something like that. Now, again, here's what you're looking for. Are the 1 and -1 the same pitch, the same steepness, but opposite signs? Should be, okay? And then the last one I'll put in the chart here, -2, 0. What do you get when you plug it in? -2 plus 0 is -2. So that has to be steeper in the negative direction, and it has to be the same steepness as this one was over here. It's not difficult, right? Is it a little tedious? Yeah. Now let's go ahead and finish it out here. You finish it on your own. I'm going to finish it on my own and we'll compare. All right. If you want to keep going with your little T chart, you can. I'm just going to try. I'm going to try to just do it in my head here. Tedious. Oh, just while I'm doing this, I know we eat in here and that's perfectly fine, but make sure that you check your area before you leave, because I picked up fruit under a desk. I picked up some of there's a fuzz ball right there or a cheese ball. I picked up a wrapper and a knife. And then if you need to wipe your desktop off, I have the Lysol and towels over there. So like some of the desks get sticky during lunch. Just, yeah. And imagine being a 5th period person coming in, sticking your elbow in a sticky substance and then squishing a piece of grapefruit under your desk. You're like, ugh, I hate math now. They start to associate it with math. And so they lick their elbow, right? Yeah.
And you're like, oh, that's actually really good. What was Jackson?
Yeah. Okay. So y'all should have gotten something that looked like this. Something that looked like this. Okay. Now, as you start filling this in, and I labeled my slopes, that you don't get credit for labeling them. The steepness, the relative steepness has to speak for itself. But I did that so y'all can check your slopes. You start noticing a pattern. Did you see a pattern here? It appears to be that the slopes are consistent everywhere down a diagonal line, right? Look what happens. Let's see. Let's see. Yeah, no. Oh, we already did that. Oops. No, I don't want to capture a quick note. Done. Okay. So let's answer the next part. Okay. What color? Purple? Yeah, okay, good. Let's do the particular solution that passes through 0, 1. Okay. For 0, 1, we make sure we hit that point right there, 0, 1. And now we go with the flow. So there's not much room on the right. You go there. And then it looks like we're going to do this and look like that, right? That would be reasonable. Okay, I'll circle this in purple so the colors match up. Now notice that if we were to continue looking out to the left, it would look like this graph here, this solution would have what type of asymptote as it goes out to the left and up forever? Doesn't it look like this would be kind of a slant asymptote? Right? Remember we talked about slant asymptotes? Yeah. Yeah, when the degree of the top is bigger by 1, remember. So it looks like it would go to infinity along the line of that slant asymptote, like a stairway to heaven, right? There's a lady, you sure? Yeah. Okay. How about let's choose orange now. If we pass through the point -1.5, -0.5, -1.5, -0.5. Whoa. Now, you would not be asked that on the AP exam because that's not a dot that they gave you. Okay. But I gave it to you. And so it would be somewhere in that vicinity, right? All right. Now, what would the general solution look like? Well, it looks like it's going to be going this way. And maybe that's going to be a slant asymptote for it as well. And then as I go out, it should be getting a little bit steeper, right? So there's that particular solution. And then the last one here, I'll use gray. Good old gray. If I pass to the point -1, 0, that's going to be right here. And what would that particular solution look like? A straight line. Yes, sir. That's the pattern I was wanting you to see, that the slopes kind of tend to be the same down that diagonal line like that. So instead of being the slant asymptote for the other graphs, it becomes the line itself. Are we almost out of time already? Holy crap. They say time flies when you're having fun. Time flies when you're doing math, but man, that was kind of like, that was like euphorically fast. All right. We will finish slope fields tomorrow for sure. Okay. Enjoy your lunch and be working on those corrections. Okay. I'll be here every morning except for today. All right. So